All of you watch the video carefully, my children. After watching the video, if you have any doubts, ask your doubts and get your doubts clarified. Okay, my children. Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss sequence and series. In this chapter, we are going to discuss the problems in the exercise 9.3, page number 192 in the textbook. In the previous class, we have discussed the concepts of this exercise and we have discussed 11 questions so far in this exercise. I hope you have understood the concepts of this exercise and I hope you have learnt well the sums which were explained in the previous class. And I hope you have done the homework sums. Haven't you, my children? Right. Now come to the question number 12. The sum of the first three terms of a GP is 39 by 10 and their product is 1. Find the common ratio and the terms. Understood this question, my dear children? Yes. The sum of the first three terms of a GP is given and their product is also given. We have to find its common ratio and the three terms of the geometric progression. Okay, my children, right. Here three terms are there in a GP. So it is convenient to take the three terms as A by R, A, AR. Okay, my children, let us take A by R, A, AR be the three terms be the first three terms of a geometric progression. Okay, my children, we are assuming that A by R, comma A, comma AR. These three are the first three terms of the geometric progression. Now, according to the given data, what is given? The sum of the first three terms of GP is 39 by 10. Given the sum of the first three terms of the GP is equal to 39 by 10. So this is the given data. How do you write in the notation form? A by R plus A plus AR is equal to 39 by 10. Yes, my children, understood this step? Right. And come to the next condition. Their product is 1. Given the product of the first three terms of the GP is equal to 1. This implies A by R into A into AR is equal to 1. Yes, my children. These are the first three terms. So the product of these three terms is equal to A by Yes, so see here, my dear children, three terms of GP, first three terms of GP is given. So, as we have given in the arithmetic progression, in the case of arithmetic progression, if you have to select, if you want to select three terms of arithmetic progression, how do you select a minus d, comma a plus d? Do you remember that point, my children? If you want to select three terms of an arithmetic progression, how do you select a minus d, a plus d? Suppose if you want to select five terms, four terms, you want to select four terms in an arithmetic progression, then what will you select? A minus d, a plus d, a minus 2d, a plus 2d. Like this, I have given a table also. Similarly, here also there is a selection of terms in geometric progression. There is a technique to select the number of terms in a geometric progression. I will give the table also. After this class is over, I will give the table. Suppose if you want to select three terms of geometric progression, how to select? If four terms of the geometric progression should be selected, if you want to select four terms of geometric progression, in that case, how to select? What are the terms should be? Like this, I will give the table also. With the help of the table, you can easily select the number of terms. According to the number of terms of GP, you can select the terms of the GP. Similarly here, three terms of GP should be selected. That is why we have assumed that A by R, comma A, comma AR. These are the three terms of the geometric progression. We have selected like this. Okay, my dear, is there? I will give you the table also. I will give you the table how to select terms of GP. Okay, ma. Yes. Now, please carry on. Please watch the YR into A into AR is equal to 1. Okay, my children. Now, let us simplify this equation. Here, R gets cancelled. Then what we get? A cube is equal to 1. Understood this step, my children? Right. Now, A cube is equal to, this can be written as 1 cube. Yes or no, my children? This implies A is equal to 1. So, we got A. The value of A is found. Now, let us substitute A is equal to 1 in the equation 1. Okay, my children? By substituting A is equal to 1 in the equation 1, we get 1 by R plus 1 plus R is equal to 39 by 10. Understood this step, my children? We have substituted A is equal to 1 in this equation. Then we get this step. A 1 by R plus 1 plus R is equal to 39 by 10. Now let us solve this equation. Here LCM is R. Then what will you get in the numerator? 1 plus R square is equal to 39 by 10. Understood this step, my children? Right. Here I wrote the last step again here. Okay, my children? This implies 1 plus R square by R is equal to 39 by 10. Okay, my children? Right. Now, by cross multiplication, what will you get? 10R square plus 10R plus 10 is equal to 39R. Understood this step, my children? Right. 10R square, let us transpose this term to LHS. So, what will you get? 10R minus 39R. What will you get? Minus 29R. I am writing here the simplified term here. Okay, my children? Right. Is equal to 0. Understood this step, my children? If you observe this equation, this is a quadratic equation in R. So let us find the roots of this quadratic equation by splitting the middle term. Okay, my children. By splitting the middle term, let us factorize the above quadratic expression. Okay, my children. So 10 tens are 100, 25 fours are 100. Yes, sir, my children. So 10r square. Now we are splitting this one as minus 25 or minus 4r plus 10 is equal to 0. Understood this step, my children? Right. This implies from these two terms 5r is a common factor. Then what we get? 2r minus 5. Okay, my children. Again from these two terms minus 2 is a common factor. Then what will you get? Minus 2r minus 5 is equal to 0. Understood this step, my children? Right. Again from these two terms 2r minus 5 is a common factor. 2r minus 5 into 5r minus 2 is equal to 0. Understood this step, my children? Right. This implies 2r minus 5 is equal to 0. This factor is equal to 0, or 5r minus 2 is equal to 0. Okay, my children? Understood this step? Right. From this equation, let us find the value of r. 2r is equal to, by transposing minus 5 to RHS, it becomes plus 5. Understood this step, my children? Right. This implies r is equal to 5 by 2. So we got here r is equal to 5 by 2. Similarly here, let us solve this equation. 5r is equal to 2. Here we are transposing minus 2 to RHS. Then it becomes plus 2. Understood this statement, children? Right. This implies r is equal to 2 by 5. Understood this statement, children? Right. We got here two values for r. Okay, my children. So case 1. If a is equal to 1 and r is equal to 5 by 2. Let us take this one. Then the first three terms. Then the first three terms of the geometric progression, or what is the terms a by r? So 1 by 5 by 2, a means 1, er 1 into 5 by 2. Understood these three terms, my children? That is equal to 1 by 5 by 2. What will you get? 2 by 5, comma 1, comma 5 by 2. Okay, my children? Understood these first three terms of the geometric progression in this case 1. Right. Now case 2. Let us take this value. Case 2. Case 2. If a is equal to 1 and r is equal to 2 by 5, then the first three terms of the geometric progression are a by r, that is 1 by 2 by 5, ar 1 into 2 by 5, that is equal to what you get here, 1 by 2 by 5, yes, 5 by 2, comma 1, comma 2 by 5. In the second case, we got these are the first three terms of the geometric progression, and in the first case we got 2 by 5, comma 1, comma 5 by 2. are the first three terms of the geometric progression. Understood, my children? Right. Now come to the next question, that is the 13th question. How many terms of geometric progression 3, 3 square, 3 cube and so on are needed to give the sum 120? Understood this question, my children? The sum of the first n terms of geometric progression is given as 120. Now we have to find how many terms of the geometric progression gives the sum of the first n terms is equal to 120. Understood this question, my children? Right. Now let us write the given data. Given geometric progression 3, 3 square, 3 cube and so on. Then here what is the first term? A is equal to, first term A is equal to A is equal to 3. Common ratio. Common ratio, that is R is equal to, how do you get the common ratio? Second term by first term. Yes or no, my children? That is equal to 3. So common ratio is also 3. First term of the geometric progression is 3 and the common ratio of the geometric progression is also 3. Let Sn denote the sum of the first n terms of geometric progression. Okay, my children. Then Sn is equal to, what is the formula? A into R to the power of n minus 1 by R minus 1, because here R is greater than 1. Common ratio is greater than 1. So we are using this formula. Okay, my children. Right. Here the sum of the first n terms of the geometric progression is given as 120. Okay, my children. So I am rewriting this one. A into R to the power of n minus 1 by R minus 1 is equal to Sn. So in this formula, let us substitute. Sum of the n terms 120 is given. A, what is A? 3 into 3 to the power of n minus 1 by 3 minus 1 is equal to 120. It is given. Okay, my children. We don't know the sum of n terms, the sum of how many terms of the geometric progression gives 120. Understood this step, my children? Right. This implies 3 into 3 to the power of n minus 1 by, in the denominator what we get? 2 is equal to 120. Understood this step, my children? Right. This implies 3 to the power of n minus 1 is equal to 120 into 2 by 3. If you are transposing 3 by 2 into RHS, it becomes 2 by 3. Okay, my children, understood this one? Right. 3 1 times 3, 40 times. Okay, my children. 3 power n minus 1 is equal to 42's 80. Understood this step, my children? Right. This implies 3 to the power of n is equal to 80 plus 1. We are transposing minus 1 to RHS, then it becomes plus 1. Understood this step, my children? Right. This implies 3 to the power of n is equal to 81. Okay, my children? So 3 to the power of n is equal to 81 can be written as 3 power 4. Yes or no, my children? Right. This implies n is equal to 4 by comparing, by equating the exponents. Here bases are equal. So we are equating the exponents. So n is equal to 4. Understood, my children? Therefore, the sum of the first 4 terms of the geometric progression gives 120. Understood, my children? Right. Now come to the next question, that is 14th question. Question number 14. The sum of the first three terms of a geometric progression is 16 and the sum of the next three terms is 128. Determine the first term, the common ratio and the sum to n terms of the geometric progression. Understood this question, my children? Right. Here the sum of the first three terms of geometric progression is given and the sum of the next three terms of the geometric progression is also given. Then we have to find the first term, common ratio and the sum to the n terms of the geometric progression. Okay, my children? Right. Let us consider the required geometric progression is AR square, AR cube, AR to the power of 4, AR to the power of 5, AR to the power of 6, AR to the power of 7 and so on. Okay, my children. This is the required geometric progression. Now what is given? The sum of the first three terms is 16. Given the sum of the first three terms of the geometric progression is 16. Okay, my children. Right. This implies what are the first three terms of this geometric progression? Yes, A, AR, AR square. Yes or no, my children? These are the first three terms. So sum of these three terms A plus AR plus AR square is equal to 16. Understood this step, my children? Right. This implies let us take A common from these three terms. A into 1 plus R square is equal to 16. Understood this step, my children? Right. Let us consider this is equation 1. Okay, my children? Right. Now come to the next part, next condition, next hint. What is the next hint is given? The sum of the next three terms of the geometric progression is 128. Okay, my children? Given the sum of the next three terms of the geometric progression is equal to 128. Okay, my children? Right. This implies what are the next three terms? AR cube, AR power 4, AR power 5. Yes or no, my children? These are the next three terms. Yes or no, my children? So sum of these three terms, AR cube plus AR power 4 plus AR power 5 is equal to 128. Understood this equation, my children? Right. This implies let us take AR cube common. From these three terms, we can take AR cube. Then what will you get here? 1 plus R square or plus R square is equal to 128. Let us consider this is equation 2. Understood this equation 2, my children? Right. From these two equations, we have to find A value and R value. Okay, my children? Right. How do you find? Divide equation 2 by equation 1. Okay, my children? 2 by 1. Equation 2 by equation 1. Let us divide equation 2 by equation 1. But then what you get? AR cube into 1 plus R square is equal to by A into 1 plus r square is equal to 128 by 16. Understood this statement, children? Right. Here a gets cancelled. Here 1 plus r square. This factor is also cancelled. Understood this statement, children? Here 16 once, 16 8 times. Okay, my children. This implies what we get, r cube is equal to 8. Yes, my children. This implies r cube is equal to, this can be written as 2 cube. Understood this equation, my children? This implies by equating the bases, here exponents are equal, so we are equating the bases. So r is equal to 2. We got the value of r. Understood this step, my children? Right. Now let us substitute r is equal to 2 in the equation 1. Okay, my children? Let us substitute in equation 1. Then we get a into 1 plus r square is equal to 16. Okay, my children, in the equation 1 we substituted r is equal to 2. Then we get this step. Understood this step, my children? Right. This implies a into what we get, 1 plus 2 plus 4, 7. That's our number, children, is equal to 16. This implies a is equal to 16 by 7. This is the first term of the geometric progression. So a is equal to 16 by 7. We got the common ratio, r is equal to 2, and the first term of the geometric progression. Now let us find the sum to n terms of the geometric progression. Okay, my children. Therefore, sum to first n terms of the geometric progression, that is equal to Sn, is equal to, what is the formula? A into r to the power of n minus 1 by r minus 1, because here r is greater than 1. Okay, my children, so we are using this formula. That is equal to a 16 by 7 into 2 power n minus 1 by 2 minus 1. Understood this step, my children? Right. By simplifying the numbers in the denominator, what we get is 16 by 7 into 2 power n minus 1. Understood this step, my children? This is the sum to first n terms of the geometric progression. Understood, my children? Right. Now come to the next question, that is question number 15. 15th question in the exercise. Given a geometric progression with a is equal to 729 and 7th term 64. Determine S7. Understood this question, my children? Right. First term of the geometric progression is given and the 7th term is also given. We had to find the sum of the first n term, first 7 terms of the geometric progression. Okay, my children? Right. S7 denotes sum to first 7 terms of the geometric progression. Okay, my children? Right. Given the first term geometric progression is 729. Let R be the common ratio. Let R be the common ratio of the geometric progression. What is given here? 7th term given seventh term of the geometric progression is equal to 64. Okay, my children. This implies, how do you write seventh term? T7 is equal to 64. A r to the power of 6 is equal to 64. Yes or no, my children? Seventh term of the geometric progression is a r power 6. This implies, what is a value here? 729. 729 r power 6 is equal to 64. Since a is equal to 729, we substituted a value in this equation. Understood this step, my children? Right. This implies r to the power of 6 is equal to 64 by 729. By transposing 729 into RHS, we get 64 by 729. Understood this step, my children? Right. This implies r power 6 is equal to, by prime factorizing the numerator, we get 2 power 6, and by prime factorization, we get 3 power 6. So we can write 2 by 3 whole power 6. Okay, my children, understood this step? 2 power 6 value is 64. 3 power 6 value is 729. Okay, my children? Right. This implies r is equal to 2 by 3. So we got the value, common ratio. Okay, my children? We know the first term of the geometric progression and common ratio of the geometric progression. Okay, my children? Now let us find the sum to first 7 terms of the geometric progression. Okay, my children? Right. Therefore, sum to first n terms of the geometric progression, that is Sn, is equal to a into 1 minus r to the power of n by 1 minus r, because here r is less than 1, 2 by 3 is less than 1. That is why we are using this formula to find the sum to first n terms of the geometric progression. Okay, my children, understood this step? Right. In this formula, let us substitute n is equal to 7, a is equal to 729, and r is equal to 2 by 3. Okay, my children, put n is equal to 7, a is equal to 729, and r is equal to 2 by 3, the above equation. We get S7. Okay, my children, what is a 729? In this equation, we are substituting n is equal to 7, a is equal to 729, and r is equal to 2 by 3. Okay, my children, right. 1 minus 2 by 3 whole power 7 whole divided by 1 minus 2 by 3. Understood this step, my children? Right. Now let us simplify this number. Then we get S7, the value of S7. Okay, my children? Right. Here, I wrote the previous step again. S7 is equal to 729 into 1 minus 2 by 3 whole power 7 whole divided by 1 minus 2 by 3. Okay, my children? Now let us simplify these numbers. This is equal to 729 into 1 minus 2 by 3 whole power 7. What is the value of 2 by 3 whole power 7? 128. 2 power 7 value is 128 by, what is the value of 3 power 7? 2187. 2187 whole divided by, let us take LCM in the denominator, then what will you get? 3 minus 2. Understood this step, my children? Right. This implies 729 into, here also let us take LCM, 2187. 2187 minus 128 whole divided by what we get here in the denominator 1 by 3. Understood this step, my children? Right. This is equal to 729. This becomes 3. So 3 into 729 into what will get 2187 minus 128. 9, 5, 0, 2059. Okay, my children, 2059 by 2187. Okay, my children, understood this one? Right. Here 729 one time, 729 three times. Okay, my children, right. Here 3 ones gets cancelled. So this is equal to 2059. Therefore, S7 is equal to 2059. The sum to first 7 terms of the geometric progression is 2059. Understood, my children? Right. Now come to the next. Yes, my dear children. Understood the sums in this exercise based on the geometric progressions. I will post this video in the Google Classroom again. You can watch the remaining sums. 16th, 17th and 18th questions are also there in this video. In this video, 3 more sums are there. 16th question, 17th question and 18th question explanations are there. Please watch the video completely and carefully. I will post this video in the Google Classroom. Okay, my children, after watching the video, prepare your classwork notes by yourself. If any doubt is there in any step, ask your doubts and get your doubts clarified. Now the time is 12 past 31 minutes. Now you can leave the meeting, my children. Take rest, take care of your health. Stay at home, stay safe, sanitize your hands frequently and maintain social distance of 2 meters away from others. And write your classwork notes, watch the videos completely and carefully. If any doubt is there, ask your doubts and get your doubts clarified. Thank you. Thank you all, my dear children. What, my dear Rexlin, still you are online? Why are you staying back online? Rexlin?
Sir. Online.
Do you want to say something?
No,
Do you
sir.
want to ask? Yes.
Internet problems.
Okay. It's okay.